lại nó tối. Dạ.
Hey guys, this is Stinger from the Ghost Squadron Airsoft team, and today I'm going to be talking about proper shimming of your AEG. Now, if you don't know what shimming is, I'll explain it to you right now. Shimming is where you take little washers like this right here and put it on the axles of the gears inside of the gearbox of the AEG. What this does is spaces the gears up and down inside the gearbox. The reason this is done is because you want to ensure the absolute best meshing of the teeth on each gear to the gear next to it that it touches. Having the meshing between the gears be better not only makes the gun sound better and quieter, but it also means that the transfer of energy between the gears goes smoother and there's less wear on the gears. By shimming your gun, you can improve the rate of fire and trigger response by actually quite a lot. I was pretty impressed when I shimmed mine. This is from my custom M4, the Wraith. It's shimmed perfectly right now, and I'm going to go over the method that I use to get it to basically just be sounding as good as it is and be functioning as good as it is from the shimming standpoint. Most guns do not come shimmed properly from the factory. Some don't come shimmed whatsoever. And that's why a lot of cheaper end guns, for example G&Gs, come sounding kind of like a dying cat. The higher end guns, such as KWA or VFC, come with these little things called auto shims on them. This right here is an auto shim. As you can see, it can go down onto the axle of the gear, and it's a spring. This kind of keeps the gear in place, however it's not tight enough to ensure absolute perfect meshing, as it also allows the gear to move and compress the spring. Therefore, auto shims are not ideal. So, a lot of people are wondering what the proper method to go about shimming is. And there are all kinds of methods that I've seen. Some people like to shim the spur gear, this center gear right here, as low as possible to the gearbox shell, and then shim the rest of the gears off of that. Some other people like to, for whatever reason, shim the sector gear to the piston. However, the most popular and arguably the best method is the Bevel-to-Pinion method, where you shim this bottom gear right here, which is the bevel gear, to the pinion gear of the motor. The reason that this method is the best is because this point right here is the most critical point throughout the whole gearbox for transfer of energy. If you'll notice, all the other gears turn on this plane right here. Even the piston gets pulled back along that same plane. However, the motor turns on a plane perpendicular to all of that, which means that the transfer of energy is going from this direction to this direction, right here. That means that there is a lot of energy that can be lost right here due to friction from improper meshing of the bevel gear to the pinion gear. This is also where most of the noise arises inside of the gearbox when the gun is functioning. So, you might be wondering, how do you go about shimming the gun the proper method? Well, the first thing you want to do is make sure you've got some decent shims. You basically just want to use any decent precision shims. The smaller you can get them, the better, because the smaller increments you will be able to make. The smallest that I've seen before is 0.05 millimeters. The smallest that came in this set was 0.1 millimeters. For the most part, pretty much shims from any company are fine. You can buy SHS shims, Lonex shims, JBU shims like I got. It really doesn't matter that much, because when it comes down to it, a shim is a shim. As long as it's precision machined, it won't matter too much. So once you've decided what shims you want and you have them in your possession, you should get down to your gearbox. Just take it out of your gun. Once you have the gearbox open, you want to take everything out except for the gears. So I've already taken quite a lot out. Here's the tappet plate. And the piston. with the cylinder. To get some things out, you might actually have to remove the gears. For example, I think I'll have to take the sector gear out just to get to the cutoff lever and trigger mechanism. I'd recommend that as you are removing this stuff, you clean it, as you really just don't want grease everywhere while you're doing your shimming. Okay, so you see I have removed everything except for the gears. Now you're going to want to pull the gears off and completely clean and degrease them, as well as both halves of the gearbox shell. When I degrease, I basically just use isopropyl alcohol, a piece of cloth, and a toothbrush, and I just clean everything off of it. Alright guys, so I've cleaned everything up. Gears are all nice and degreased. Now what you're going to do next is shim the gears to the gearbox. This first step is just to ensure that the gears can spin freely on their own inside of the gearbox. Then we'll work on shimming the gears to each other later on. So what you're going to do is take one gear at a time with no shims on it, put it inside one half of the gearbox shell, and put the other half on. Screw the screws in to ensure that it's fitting as tightly as it would in a real scenario with the gun fully assembled. Now, you should be able to see that there's tons of play in there. I'm able to move the gear up and down, which means that there's a lot of free space. You don't want this because you don't want the gear to be able to move while you're using the gun. Obviously that would mean that the gears would be meshing badly. So what you're going to do is now take it back apart and add shims to the gear. Make sure you put at least one shim on each side of the gear, just to ensure that there is no side that is basically flush against the gearbox. That could cause it to rub like that against the gearbox. You don't really want that. So at least one on each side, and you will end up having to put multiple on one of the sides. I suggest you just put one on like this side and then put all the rest on this side. And what you're going to do is, once you put some shims on, you're going to put it back together and test it. Now, if the gear is still able to move like this, up and down, inside the gearbox, it means you need to add more shims. However, if it's in there, it's not able to move up and down, and you can't spin it freely like this, it means you need to take shims off. So what you're going to do is put as many shims on that you can put on to the point where it's able to spin freely and it's not able to move up and down in here. It's going to take a lot of trial and error, and I suggest that you do it until you are at the point where if you were to add one 0.1 millimeter shim, it would lock up and wouldn't be able to spin freely. But if you took one 0.1 millimeter shim off, it would be able to spin freely, but it would also move a little bit when you did this. You want no movement up and down here, but you want it to be able to freely spin inside. You have to do that for each gear. I'll show you what it should look like when you're done. You can see that I cannot get it to move up and down upon its axle. It's in there very tightly, so it doesn't move up or down like that. However, it spins perfectly free. That's how it should look like for every single one of your gears after you shim them to the gearbox. However, this is only the first step, as now the gears have to be shimmed to each other. At this point, you won't need any more shims. All you're going to be doing is moving where the shims are on each gear around. If you were to add shims, one of the gears would be unable to spin freely inside the gearbox. If you were to take them away, the gear would be too loose. So as a result, what we're going to do is basically just move shims from one axle of the gear to the other axle of the gear until the meshing of the gears are perfect. And we're going to start with the bevel gear, because as I told you before, that is where the most important transfer of energy occurs. So, to shim the bevel gear to the pinion gear here, we actually need to put the motor into the pistol grip and then attach it to the gearbox. When the gear sits inside of the gearbox, it sits like this, and the pinion gear comes in like that. What you want is to lift, using the shims, the bevel gear up just enough so that it is floating right above where it needs to be on the pinion gear. Hold them like this and put the pistol grip in. Now, if you have too few shims on the left half of the bevel gear, you should notice that the pinion gear actually pushes it upwards as you insert it like that. On the other hand, if you have too many on the left half, you'll notice that they won't touch at all, and there will be no movement as a result of inserting the motor with pinion gear into this. What you want to do, if you notice that it's being moved upwards like that when you put the pinion in, you want to move shims from this side of the bevel gear to this side. Move them in the smallest increments possible until you notice that it's not being moved up like that anymore. On the other hand, if you notice that the bevel gear teeth are actually floating above the pinion gear, move shims from the left side to the right side. Do this until the meshing is perfect, and the pinion gear just slides right in without making any movement whatsoever, but there is still maximum contact between the two tooth surfaces. Once you have done that, the bevel gear will be perfectly shimmed to both the gearbox and the pinion gear. So to check to make sure that the bevel gear is shimmed perfectly to the pinion gear, put the gearbox back together with only the bevel gear in there. Put together the grip with the motor plate on it, and then basically just connect the grip with motor onto the gearbox here, so that the pinion gear is actually inside connecting to the bevel gear. Take something small like this and just try and wiggle the bevel gear back and forth. If you have more than 2 millimeters of movement, you need to lower the bevel gear down onto the pinion gear, which means you basically take shims from the left side of the gear and put them on the right side over here. If you're looking at it sitting inside the gearbox with the gearbox open, you'll have to take them from the bottom and put them on the top. Now, if you can't wiggle it very much at all, you do want some movement, but if you can't wiggle it too much at all, it means it's too tightly shimmed onto the pinion gear, and you have to do the opposite, where you take shims from the right half of the gear and put them onto the left half of the gear. Next, put the wiring harness back in the gearbox with the trigger. Put the two halves of the gearbox shell together, screw them together, take the pistol grip and motor, screw it onto the gearbox, and just kind of test fire it. The gear should spin freely and should sound pretty good. If that all checks out, the next thing that we're going to do is shim the spur gear to the bevel gear. So to do that, what you're going to do is put both the gears in the left half of the gearbox shell at the same time, and basically just look at them. And what you want is the bevel gear to be just higher than the spur gear. Now, you don't want to mess with any of the shims of the bevel gear, because that's already shimmed, or it should be shimmed perfectly to the pinion gear already. So what you're going to do is, if the spur gear isn't close enough to the bevel gear, obviously you'll take some shims and put it on the bottom of the spur gear. Take some shims from the top and put it up. Now, if they're touching and scraping on each other, they're like these two surfaces right here, this big flat surface here, and the basically the equivalent surface, which is right there, of the bevel gear. If those are touching, rubbing together, you definitely don't want that, so you're going to put some shims, take some from that half of the spur gear, the left half, and put them up on the right, or the top. Basically what you want is a millimeter or two of space between the two surfaces of the gears there, but you want the teeth themselves of the gears to be meshing perfectly, so kind of like we did before with the bevel gear and pinion gear. You want the most tooth surface area touching between the two gears. What you should end up with is basically this. You can see that there is a tiny little spot right there where the light is coming through. That's the gap between the two gears. However, the gear meshing is just perfect between the two, plenty of surface area there. Every time you do something, you change where shims are, you should stop, put the gearbox together, put 3 screws into it just in the general area to hold it together, and test it. Make sure everything's spinning fine. So if you're shimming one gear to another, put those 2 gears in, put it together, test the shimming on that. Doing that will make it so that if something does get messed up, you do something wrong, put shims in the wrong spot, whatever, you'll catch it at that point rather than catching it, 3 steps later on, where then you have to basically start everything over again. Because you don't know exactly where, you may have put too many shims or too little shims, and if you got multiple gears in there, it takes a long time to try and troubleshoot that, and lots of times it might just be better to start over. So even though it's kind of painstaking and takes up a lot of time, you should still check the shimming on it every step you make, basically, so that you can undo it. Hit the undo button if something isn't right, and redo that. So this is all shimmed properly here. The bevel is shimmed to the pinion, the spur is shimmed to the bevel, and both gears are shimmed to the gearbox. Finally, we're going to shim the sector gear to the spur gear using basically the same method. So you want the same kind of thing where there's just a little bit of space between the flat surfaces of the gears and optimal space, optimal touching surface area between the gear teeth themselves. Hopefully you can hear that. That's the sound of the surface areas of the sector gear and spur gear scraping against each other because I pulled a shim off the bottom of the sector gear. So I'm going to put that on, and that should fix that. Alright, so now you notice it's pretty much silent as I turn these. That's because they're not rubbing together anymore. And if you look in there, there's just a tiny little space, about a millimeter, between the 2 flat surfaces of the gears. So now the gears are all perfectly shimmed to each other and to the gearbox. Now it's time to test it. So what you're going to do is to put the other half of the gearbox shell on and close it up. So now you're going to want to check to make sure there's no movement up and down on the axles here. If there is, that means you did something wrong and you might have to start over. There's no movement there. And then the next thing you want to do is to make sure that it can spin freely inside, and that nothing is hanging it up at all. So you can see it spins for quite a few rotations after I spin it up through here with my finger on the sector gear. So the gears are perfectly meshed. They're not too loose, but at the same time they're not too tight, and that's the way it should be. Next, we're going to reassemble everything to test it. So what you need to do is put everything back in, reassemble the gearbox, and re-lubricate everything. Alright, once you finish up with that, put it all together, wire it up, just give it a quick test fire. If it sounds good, then you're all set. I hope this video was helpful to you guys. Hopefully you guys will go out and shim your guns well, and we'll have a lot of nice, well-running guns at the field. I also hope you enjoyed the video, and I'll see you guys later.
Ghost is back here. Yep. Oh, did he? Yeah. Pretty sure I hit Frankie. Whoa!